Okay, so hello and welcome back. Now in this video we will talk about a couple of models for addition of numbers in mathematics. Now we are at the fifth chapter of class 1, and you know the book for class 1, when you download it, you have not more than 13 chapters. So that's chapter 1, 2, 3, 4 and so on and so forth, all the way up to 15. These are, we will move essentially from class 1 all the way up to class 5. That's the basics of mathematics. The simple basics of mathematics for very young children, meaning in the primary school. But and of course these are like games and stories and things like that, but they are super important because of the fact that when we were in school, when we were much younger and in school, in the primary school, normally what you do is that you're typically, of course, very young, and so you don't pay attention to essentially what's actually going on in these lessons. But then later on, you're supposed to use them all of these models, you're supposed to use them in calculus. And so you need to know, you need to have formed these models in your mind absolutely consciously, which is something that doesn't happen normally in school. So as a result, basically we are doing these videos over here so as to compensate for that. Okay, now about addition. So a simple model that you can use for addition is that you can see that, for example, we have 4 kids over here, we have 4 kids over here, and another 2 kids over here. If you want to know how many kids we have in total, that's essentially you put all of them together, of course. So that's 4 kids plus 2 kids, and then all of them together would be 1, 2, 3, 4, 5, and 6 kids. Which means that 4 children and 2 children together make 6 children, or 4 plus 2 is equal to 6, right? Or for example, we have 3 tops here and another 1 top over here. Now these are separate now, but then when you put them together, you have basically the 3 tops and the 1 top. So that's basically 1, 2, 3, 4 tops together, which means that basically 3 plus 1 is equal to 4, right? Or if you have, for example, 3 ants over here and 2 ants over here, together you have 1, 2, 3, 4, and 5. So 3 plus 2 is equal to 5. If you have 4 pencils over here and 3 pencils over here, together you would have 7 pencils. So 4 plus 3 is equal to 7. Again, if you have 6 balls over here and 2 balls over here, together you would have 6 plus 2, which is equal to 8 balls, right? And of course you can count all of these. There is what is 6 plus 2? 6 plus 2 is essentially when you put all the 6 balls and all the 2 balls, essentially you put them together. Now you can imagine that you have essentially that these balls are all together basically. So then you can start counting 1, 2, 3, 4, 5, 6, 7, 8. So which means that essentially 6 plus 2 is equal to 8, right? Or if you have 7 stones over here and 1 stone over here, then you put them together, you'll have basically 8 stones, right? Now we can, of course, this process we can make it a little bit more formal, meaning that instead of random objects like basically a couple of stones or a couple of balls, or basically a couple of pencils, a couple of ants, a couple of tops, or a couple of children, what we can do is that we can use a more formal model. And the model that we can use would be, for example, fingers. And of course, you know that, and there is good reason for that, because of the fact that I've heard that fingers were the primary tools that were used by humans when they started counting. So even today, even when I want to count, I count things on my fingers. So I have three, essentially each of my fingers has essentially three sections. So I say, for example, when I'm talking, of course I do this, I mean, it comes naturally to me. I say, this is the first point, the second point, the third point, the fourth point. And I mean, when I want to put something in my mind, and so, I mean, when I want to essentially talk about something, and that thing essentially has different parts, and I want to not to forget what I'm going to talk about, mentally I put all of those items on my fingers, and then once I'm talking about it, I go through it essentially on my fingers, meaning that I'm practically actually kind of counting on my fingers. But essentially in this model, for example, each finger has been taken for one object. Okay, so so I have basically, and now to make this model, this counting model or this addition model more formal, you put essentially, for a 4 you put 4 fingers up, for a 3 you put 3 fingers up, then you can write essentially 4 plus 3 is equal to 7, for example, or 3 plus 2 is equal to 5, or 5 plus 3 is equal to 8, or 4 plus 0 means the absence of any fingers, right? Meaning that there is actually nothing there, right? So 4 plus 0 is equal to 4, or 4 plus 4 is equal to 8, and so on and so forth. Okay, now the same thing, the same game of addition, you can play it on dice. So you have essentially have a pair of dice over here, and then you have to throw the dice, of course. When you throw the dice, you have essentially always there is this one face of dice that comes up, and then you would count that as your, as the result of throwing the dice. And so basically then you have, for example, this face up, you have a pair of dice, so you have essentially 2 pieces, and so this is one piece and this is the second piece, and these different children are throwing the dice, and then the results are over here. So you see, for example, that's a 5 and that's a 1, so that's 5 plus 1 is equal to 6, or that's a 4, that's a 1, that's essentially 4 dots basically on the face of the dice. So that's a 4 and that's a 1, that would be a 5. That's a 2 and a 2, so 2 plus 2 is equal to 4. Or 2 plus 5 is equal to 7. Or 1 plus 4 is equal to 5. Or 4 plus 4 is equal to 8. Or 3 plus 1 is equal to 4. Or 2 plus 3 is equal to 5. Or 4 plus 2 is equal to 6. Or 4 plus 3 is equal to 7. Right? So the same game you can play it on a pair of dice basically, right? Now the same game you can play it on something like an abacus. So you have seen abacus before. So this is an abacus. So these are different types of abacus. And essentially what you have in an abacus is that you have essentially basically all of these different beads on a rod basically, and the beads you can move them around. So you have basically 1 2 3 4 5 6 7 8 9 10, again 10 beads, again 10 beads, and so on and so forth. So in every row, or essentially in every column, you have 10 beats. There are some abacus. Now what they have done in a different species of abacus is that instead of using essentially 10 beats on each row, they have used essentially in total 7 beats on a row, meaning that you have 5 beats over here, and then you have 2 beats over here, and then essentially these 2 beats over here, this essentially each of them represents essentially 5 beats, meaning that if all of the 5 beats, if you move them up, then you move down essentially, or essentially you move up essentially one of these beats. Again, if you move this essentially the same 5, if you move them up one more time, then the other one you will also move up. When both of these beats are moved up, that means essentially all the 10 beats are essentially moved up. That's nothing essentially, that's simply to save some space and to save essentially some beats basically. But this is essentially, I mean to me, this variation is a more natural representation of our number system, meaning that there is simply 10 bits over here, another 10 bits, and another 10 bits, and so on and so forth, right? Now you can imagine that this thing over here, this is a bead string. In these books, when sometimes this thing has been referred to as a ginlari. Ginlari is actually a Hindi word. Gin, or essentially gin in the Hindi language, that means to count, and lari means some rod kind of thing or something like that. So that's basically a counting string or bead string basically. And you see that we have basically 1, 2, 3, 4, 5, 6, 7, 8, and 9, and 10. So we have 10 beads over here, or again 10 beads over here, and so on and so forth, right? So this complete string of beads, you can think of it as essentially as one of these rows or one of these columns on an abacus, right? That's basically a good tool for counting basically. Now if you want to do counting on a ginlari, or essentially bead string, what you will do is that essentially you have, for example, 3 plus a 4. So you have 3 beads over here, and then another 4 beads over here. You can put them together, and of course these beads on this string, you can move them around, and then you will move all of these beads all the way up to here to one side of the string, and then you can count it, meaning that you can say 1, 2, 3, 4, 5, 6, and 7, which means that 3 plus 4 is equal to 7. And for your own, I mean, way back then when I was I mean, my very early days in mathematics, I was very much interested in abacus, in abacuses, and so I bought my own abacus back then, and then I mean, whatever I wanted to calculate, I would calculate using an abacus. Of course, on the abacus you can do essentially all the 4 basic operations. You can do simple addition you can do very easily. Subtraction you can do very easily. You can even do multiplication on an abacus. There are some techniques that you need to learn to do that. You can do even division on abacus. There are many more things that you can do on an abacus. You can even build your own abacus. You need only a couple of simple rods and a couple of beads, and then you can simply make your own abacus. Okay, and then using that you can do counting and calculation and all of those things. So then, for example, 4 plus 2, you would essentially put 4 of these beads to move them to one side of the string, and then another 2 beads you would move to the same side of the string, and then you would start counting. 1, 2, 3, 4, 5, and 6, right? A 5 and a 4 would be a 5 and a 4, move all of them to one side, and then that would be essentially a 9. A 2 and a 7 again would be a 9. A 7 and a 3 would be a 10, and so on and so forth, right? Now, another way that you can display out that you can play this game of addition is by essentially by jumping on a number strip. This you can call the number strip. That later on we will develop this into a number line basically. But for now you can think of it as a strip of paper, or essentially a couple of grids on the ground. You can essentially build. Children usually do that. They make essentially using chalk. They make these grids on the ground, and then they keep jumping in them, and then they put numbers in them and they jump, and that's a basically a very famous game among children, of course. So you can call it a number strip. You can create this, you can make this on the ground, or you can even make this on a small piece of paper, and then you can jump, meaning that, for example, for a 4 you start at 1, and then you come all the way up to number 4, right? Now on a number strip you can see that essentially on the Ginlari, basically, if I were to represent a 2, for example, I would mark the first beat and then also the second beat, right? That's basically a 2. And the first beat represents a 1. The second beat represents essentially the second number, or essentially 2, right? Now on the number strip you have the exact same deal, meaning that the first grid is going to be number 1. The second grid would be essentially, the second grid would be number 2, and so as a result, of course, the third grid would be number 3, the fourth grid would be number 4, right? So if I want to represent the 4 on the number strip, then of course I have to move from 1 all the way up to 4. That means essentially the number 4, or essentially 4 beats, right? And then I want to represent a 2, so I need to from 4 I need to jump another 2 numbers. I'm at 4, so 1 number and 2 number, I will end up at 6. So then essentially 4 plus a 2 would be essentially a jump from the first grid, and essentially starting from number 1, a jump to 4 and a jump to 6. That would be essentially the result of this calculation. 4 plus a 2 would be a 6, right? Or essentially a 3 plus 2, a 3 would be represented by a jump from the first grid, which is essentially number 1, and then you jump essentially 3 grids, which means that then you will end up at 3, and then from 3 you have to jump another 2 grids, which means that you will end up at 5. So 3 plus 2 would be a first jump and a second jump, and then you will end up at 5, right? Of course you can add as many numbers together as you wish, meaning that, for example, a 3 plus 2 plus a 2 plus a 5 plus a 7, for example, would be a jump from 1 to 3, and then another jump 3 to 5, and so on and so forth, and then you have to jump essentially 4 times, and then you will end up somewhere on the number strip. That would be essentially the result of your calculation, right? Or essentially a 5 and a 3 would be this jump and this jump over here, and then you will end up at 8. A 6 plus a 3 would be this jump and this jump over here. You will end up at the 9, right? Now in order to write down your addition, there is essentially 2 ways to write it. Depending on the situation, you will choose one or the other. So essentially, normally when you just want to write down 2 plus 3, you would write it this way in a linear way. But then when you want to actually do some calculation on the numbers, you will write them essentially in columns, meaning that, for example, you would write 2 plus a 3 is equal to, for example, a 5, or 5 plus a 1 in a linear or essentially in a column, 3 plus 3 or 3 plus 3, and so on and so forth, right? So that's essentially all the different ways that you can do, I mean, at least some of the different ways that you can do addition, and essentially some of the models that you can use in order to do so. I'll see you in the next video, and thank you.